This is geometry, working with Unit 4. We're going to talk about the first day of CPCTC. That's one way to phrase it. Another way in an if-then statement is if two triangles are congruent, then corresponding parts are congruent. So think about what that says. If two triangles are congruent, then the corresponding parts are congruent. What we've talked about before is congruent triangles have congruent corresponding parts. That's what we spend time in a proof trying to show. So if you can prove that two triangles are congruent by using three pairs of information, typically something that looks like this, either three sides or two sides in the included angle, or two angles on the included side, two angles in the non-included side, or RHL. If we can use three pairs of corresponding parts, then you know that the other three corresponding parts that we haven't used yet are also going to be congruent. That's what this means. If two triangles are congruent, then the corresponding parts are congruent, even things we haven't talked about yet. So let's come on down and give it a try. So we're going to look at segment AB. It's congruent to DE. So I would encourage you to mark that on your figure. We could put one tick mark on that. Angle ABC, so follow the letters A to B to C and put a curve marker in there because it represents the angle. The vertex is the middle letter. Angle DEC would be over here. So far we have two bits of information. Before you start working actually in the actual proof, work on a plan. What do you see? What do you notice? We also have our third bit of information because we have a big X here. We have vertical angles. So now I can show the triangle is congruent by angle, angle, side. That's one of my 5 ways. And if the triangles were congruent, then I can show this additional bit of information, ones we haven't even talked about yet. This segment over here, DC, is congruent to this segment here, AC. So that's our plan. So we know we've written down our given. Our extra piece of information was our vertical angles. So angle ACB, we got to use 3 letters to name these angles because we have adjacent angles at that point. It's congruent to angle DCE if vertical angles, if is going to come earlier. In this case, it's coming so early it's in the picture. So if the picture says so, then if vertical angles, then congruent angles. Every time we have vertical angles, you know those angles will be congruent. So now we can show that the triangles are congruent because we have 2 A's, 2 angles with the non-included side. So that's AAS congruence. Now since we have the triangles congruent, that's where we stopped before. But now we're able to take an extra step. We're able to show other things we did not know before. One of those would be this extra pair of sides. DC is going to be congruent to AC. If two triangles are congruent, which we have, if comes earlier, then it's coming right now. Then corresponding parts are congruent. You could even say corresponding sides, because these are sides. I would be okay with you saying corresponding sides are congruent, but parts is generic enough. There is abbreviation. The abbreviation for this is CPCTC. Your book won't use the if-then statement. The book's going to use corresponding parts of congruent triangles are congruent. CPCTC. It's saying the same thing. We've talked about a lot of if-then statements in the past. If comes earlier, then comes now. So I think the if-then statement helps you create and continue the pattern we've been talking about. But if you use CPCTC, that would be just fine. All right, we'll slide up to our next one. So take a look at what we have here. Put some marks on your figure. Figure out what we're going to use here and what we're not going to use. This picture's a little bit more involved than what we need. Can you figure out what triangles we're going to use? Can you figure out how you're going to prove those triangles congruent? That's called your plan. So go ahead, pause the video, try that, then come on back, we'll talk you through it. So what we see is that BD is congruent to CD. We should all have marked our segments congruent. Angle BDA, that would be this angle, is going to be congruent to CDA, which is that angle. So we have two bits of information so far. We have a side and an angle. We're looking for the third thing. If you look closely at your picture, you'll notice that we have this reflexive side. Now, it might require you to notice what you're trying to prove. We're trying to prove that BAD, we're trying to prove this angle at the top is congruent to the one right next to it. So that means the two triangles right and left need to be congruent. That looks like what we're working with. We've got segments of each of those. We've got angles of each of those. So we have our third side. So it looks like our triangles are congruent by side, angle, side. And if the triangles are congruent, then the corresponding parts are congruent. So we're going to start out with number 1 as BD is congruent to CD. That's our given. Our other part of given is angle BDA is congruent to angle CDA. So we've labeled down what we know. What you have to decide is there something else that we can say from those statements? From those exact statements. Like, if it's a midpoint, we have something else to say. If it is perpendicular, we have something else to say. But in this case, they're just congruent parts. There's nothing else to talk about them. So we're going to move on to our new piece of information. DA is congruent to DA. And that would be a reflexive POC, property of congruence. Now I have side, angle, side of each triangle. So I'm ready to say that my two triangles are congruent. That ABD, triangle ABD, is congruent to triangle. Now I have to say this in the same order. ACD. If I went ABD down this long side and up the one ticker, I have to go down the long side and up the one ticker, ACD. It's important that you label the second triangle to match the first triangle. And we use one of our 4 ways to prove triangles congruent. So what we've talked about is 5 different ways to prove triangles congruent. In this case, side, angle, side, because the angle we have is in between those 2 A's, or those 2 sides. The A is in between the S's. Once you know the triangles are congruent, then we know any extra parts that we haven't talked about. They must be congruent. We haven't talked about these angle A's at the top. That this angle A, BAD, this one here at the top and the other one on the side, those are going to be congruent. If triangles congruent, then corresponding parts congruent. You could also call that CPCTC. Corresponding parts of congruent triangles are congruent. I like the if-then statement, but either way will work. Our last one, we're going to take a look at this situation. Notice the double line here, that stands for parallel. So AB is parallel to CD. So we look up here in our picture. AB has one arrow, DC or CD has one arrow, so they're parallel to each other. Segment AD and segment CB are also parallel, so they have a different number of tick marks. So think about what you need to do with parallel lines. What do we typically talk about? We're usually looking for one of 4 types of angles. And then how can that lead us to help us get triangles congruent? So then we can prove other corresponding parts congruent. Go ahead, pause the video, make yourself a plan, mark it up on your figure, see how you do, come back and check it out. So we notice that we have AB parallel to CD. And if we somewhat highlight that out in our transversal, you'll see we'll have a zigzag. And that zigzag creates alternate interior angles. So we know that those angles are congruent. Then we have another pair of sides that are parallel. And they have their own transversal. Happens to be the same one. And they create another pair of alternate interior angles. That's the common type of angles that we see with parallel lines when the shape looks like this. So I have 2 A's and I have the S that's in between because that's the reflexive side. So I can prove the triangle is congruent by angle, side, angle. I made my plan. You have to make a plan before you start writing. So number 1, we know that AB is parallel to segment CD. And segment AD is parallel to segment CB. That was our given information. Is there something that we can talk about from that given information? And the answer is yes. We have those alternate interior angles. We have angle ABD. That has one tick mark on it. And the other one with one tick mark is CDB. Notice you have to use 3 letters to name these angles. You cannot say angle D, because I don't know which one you're talking about. We also could say the 2 tickers, ADB, and the 2 ticker, CBD. We know those are congruent if 2 lines are parallel, then alternate interior angles are congruent. We know from our yellow sheet that if you look at your yellow sheet, if lines parallel, if parallel lines, you have several different options. You have each of the different types of names. We're using alternate interior, then they are congruent. So that's the one we're using. So we have shown 2 sets of angles. Now we need a third piece of information. We talked about how that was going to be the segment that's in the middle, the segment that's being shared between the 2 segments. From the 1 ticker to the 2 ticker, we're going D to B. In the other triangle, from the 1 ticker to the 2 ticker, we're going B to D. So notice the order has changed. That's called the reflexive POC, property of congruence. Now we've shown the angles are congruent, the sides are congruent. So I'm able to say that the triangles, I can name the first triangle any way I want. I'll name it ABD, is congruent to triangle. Now I have to say it in the same order. A was out here, so I have to start mine with C. Then I went to the 1 ticker, so I have to go to the 1 ticker, which is D. And then over to the 2 ticker, so up to the 2 ticker, so B. That was done by angle side angle congruence. And if we have our 2 triangles congruent to each other, then we know their corresponding parts. This is one set of parts that must be congruent. The next bit of information that we wouldn't have known, but if the triangles are congruent, then the first 2 letters go with the first 2 letters. And the first and last letter goes with the first and last letter. AD has to be congruent to CB. If the triangles are congruent, then the corresponding parts are congruent. If triangles congruent, then corresponding parts are congruent. We could call that CPCTC. Corresponding parts of congruent triangles are congruent. Good job, everybody.